So today is going to be our first major traffic scenario of our self-driving car simulation. We're going to see if we can observe the traffic Ouroboros. This is a phenomenon that happens when you've got cars traveling around in a loop and one of them breaks, just one. And the braking gets passed from the car that brakes to the car behind it, to the car behind it, to the car behind it, until eventually the car that broke? The car that slowed down initially catches back up to the braking pattern and has to brake. So even though that car has long since made its way around the loop, it now has to continue to pass along the braking. Now, this is attributed to the limited reaction time of humans, of monkey drivers, as C.G.P. Gray likes to call them, and supposedly it gets taken care of, meaning eliminated, when you have self-driving cars that don't have that limited monkey brain reaction time. So what we've done here is set up an array of cars. We've got 14 cars total on this nice square loop. The shape doesn't matter too much because the cars are able to navigate the turn just fine. So all of these cars are obeying the code that we set up last time, where they look ahead to each lane piece that's in front of them until they see a car, and then they either brake or match the speed accordingly. One of these cars is going to be the test car. So we had a test car last time that was speeding up, slowing down, speeding up and slowing down. I've made some changes to test car to test the traffic Ouroboros. So what we're going to check for in test car this time, let me zoom in for you. There we go. Now I need to find test car again. There we go. What test car does this time is, if the car in question is a test car, meaning if that box is checked as true, and the time since the level has loaded is greater than the amount of time it would take to get up to speed. So this time to excel, we've got it calculated up above somewhere, is basically the amount of time it takes for the cars to get up to speed. And we're going to add to that 50%, just so that way we get all the cars up to a nice consistent speed, so that traffic is moving steadily. We're in a steady state before the car brakes. And the car is going to brake for that amount of time plus, after that time plus this additional amount of time to brake. So this is calculated as the amount of time it takes for that car to slow down. And all those are based on the speed of the car and the braking and acceleration forces. And then what we're doing is we're going to have that car brake. I mean, we're going to apply the braking force to it for that specified amount of time. So in other words, the test car is only going to be braking for a brief window of time. Now, I've also had to keep track of what the cars are doing. So I've defined this new variable myState for each of our cars, and that can have the values brake, excel, and I think coast, is it? Let's see, what else can my state be defined as? So it can be brake, and it can be, what is the next one? Yeah, there's a lot of braking going on, obviously. And it can be accelerating, and there's technically an option for coasting, but I haven't actually set any of them to coasting because we're basically looking for whether they are braking or accelerating. Coasting is just sort of the default. The reason I need that is because I'm using that to keep track of the delayed reaction time for our monkey drivers. So I've also added in a Boolean called monkey driver. Let's go to where that is first. So its default value is false because we would like to be working with self-driving cars in our self-driving car sim, but we want to be able to compare the behavior of the self-driving cars to cars with monkey drivers in them. And so what we do is, if we have a monkey driver, then we give them a reaction time. So I've set the reaction time currently to be half of a second. That's a decent order of magnitude. It's also enough to show the impact of the reaction time in the simulation. I played around with it a little bit. And so what we're doing is we're checking for whether we have a monkey driver. So for example, if we determine that we need to slow down, so we've seen this last time, this is you are getting too close to the car and your speed is greater than its speed. Then what we're doing is we're checking for whether the car has been braking. So if the car has not been braking and the car is being operated by a monkey driver, then what we have to do is we have to set up the time to change. And this is the current time plus the reaction time. So this is 0.5 seconds into the future. Then what we do is if we've already set our state to braking, meaning we know we need to be braking, we just haven't overcome the reaction time yet, then if the reaction time is passed, so if the time since level load is greater than time to change, or if we're not a monkey driver, meaning we're in a self-driving car, we don't worry about the reaction time period, then we go into the braking. So in other words, there's half a second delay between identifying between the need to brake arising and the actual instigation of braking. And then we've got the same type of thing below for acceleration as well. So if we say, for example, need to accelerate to match the speed of the car in front, then if we need to be accelerating and we're a monkey driver, then we have the same snippet of code down here. We need to add on the reaction time to get the time to change. And if we have passed the reaction time, then we're ready to accelerate. So we've got a delay in reaction for both accelerating and for braking. So in the first scenario we're going to look at, I've set up this car here, the braking car, to be our test car. So keep an eye on the car that starts in the upper right corner, because it's going to be the one that brakes first, interrupting the nice smooth flow of traffic. All the other cars are not test cars, they are regular cars, except they've all got monkey driver selected. So these cars are all being operated by humans with that half a second reaction time. That's for our first scenario. Now, I've played around with this a little bit, and since we have so many cars running, it runs a bit slowly when it's in the Unity preview, but it runs just fine if I build it and run it separately. So what I'm going to do is cut here for just a second. We're going to build the simulation, and then we'll run it and watch it together. Okay, here we go. I'm not sure why the cars are so much taller. I think I messed up something with the camera, but so pretend they're all, British double-decker buses or something. So our cars are coming up to speed. They are going to maintain that following distance between each other pretty well. I've already lost track of which car it is that is supposed to brake, but it'll be pretty obvious when the thing brakes. Oh, there it goes right there. So this car has broked. These cars don't know it yet because the braking wave has not traveled back this way. So this car has braked. The chicken is crossed in front of it. It no longer feels the need to brake. So now it's saying, oh, I can accelerate because there's space in front of me. But the drivers in these cars are all having to brake. Now keep your eye on this car right here, or this one. One of these two is the one that was the original braker. So you notice that the braking wave is traveling back this way. It's traveling along to the other side now, and so at this point the braking wave has traveled back around to the original car that had to brake. And so now again, because of this finite reaction time, we almost have a collision there. Almost. There's just a little bit of space in between there. So this braking is traveling back, so it's like a snake that is eating its own tail going around this way. So that's why it's called the traffic Ouroboros. And so just because of that one braking maneuver that happened over here earlier on in the simulation, we now have to have everybody brake going back around. Now I've got sufficient space between the cars. It looks like it gets itself cleared up by now, but you notice that traffic Ouroboros traveled back all the way around to here. So it started over here and ended up back around on this corner. So it traveled almost, let's call that halfway around the loop. So what I'm going to do next is have the comparison case. We're going to turn off the monkey driver. So we're going to say that this is a world now in which everybody on the road has a self-driving car. So we no longer have any monkey drivers. I'm just going to manually go down here and check to make sure that that worked. Okay, we have no monkey drivers on the road now. So we're going to save. And again, we'll build and run, and we'll see what the difference is. Remember, last time the braking wave, the traffic Ouroboros, made it about halfway around the loop before the braking wave broke up. Okay, so our self-driving cars are going to start out in the same pattern. They're accelerating up to the speed limit. They've got the same following distance. Again, the only difference between this scenario and the last one is that now we have that reaction time. We've got self-driving cars, computer-driven cars, instead of monkey-driven cars. And so we should be getting our brake here. What you'll notice is that since this car is able to react faster, we get a much greater distance between the two for it to come to a stop. We get a little bit more distance there, a little bit more distance there. And so the traffic is able to clear up much faster. The traffic wave only travels from here to here. It travels about 5% of the loop rather than 50% of the loop, which is a pretty big difference. So which road would you rather be on, the first one or the second one? I would choose this one any day of the week. Okay, let's try one more scenario, because this is the one that comes up a lot in discussion, is, well, what if you have a mixture of self-driving cars and monkey-driven cars in the road? Which is an excellent question, because obviously there's going to be some transition between having all monkey-driven cars and having all self-driven cars. And so what I'd like to do here is put in one monkey driver. Let's see. So this is the car that's going to brake. Let's have that be a self-driven car. This is the car that'll brake behind it. This is the one that's oops, I did not mean to move that car. I want to go with this car. There we go. So let's say 2 cars back, there is a monkey driver. So everybody on the road has a self-driving car except this one monkey driver. Maybe he's on his way to getting a self-driving car. Maybe he's a late adopter. Maybe the computer in his self-driving car has broken down and he's having to drive manually. Who knows? Although in that scenario, you just have a self-driving car come pick you up. That's the beauty of it, is that it doesn't have to be your self-driving car solely, but I'm getting off on a tangent there. So here we've got our one monkey driver. Let's see what difference it makes when we've got a single monkey driver in the driver's seat. Okay, so our braking car is over here. Our monkey driver is over here. Again, everybody's getting up to speed just fine. The monkey driver is fitting in fine with the self-driving cars. No one has any reason to suspect that it's a monkey-driven car. And we're coming around here. We should be getting our brake right about now. All right, so again, this one is able to react fine, so we get a nice distance in between there. The monkey driver, on the other hand, that's a little bit closer. And of course, he doesn't accelerate as soon as the self-driving car did before. Okay, so we end up with not too bad of a slowdown. So, so one out of every, how many is this, 15? 1 out of 15 monkey drivers is not so bad. Excuse me, 14. I guess we have 14 drivers. So 1 monkey driver out of 14 is not so bad. What if we add a few more? So let's see. So this was this is currently our monkey driver. Let's go back a couple more. Add in another monkey driver. And let's go back a couple more, add in a monkey driver. Okay, so here we go, starting up again. So to remind you, this is our braking car, and then we've got monkey drivers interspersed with self-driving cars after the braking car. So what'll be interesting to see is how well the self-driving cars can compensate for the fact that we have monkey drivers on the road. Let's see, we've got our brake there. We've got a successful brake here. Here comes our first monkey driver. Again, you can see that there's less of a gap here than there is here because of the reaction time. But what we see is that our self-driving car here is able to adjust sufficiently that it doesn't matter that we've got monkey drivers behind it because of the self-driving car ability to compensate for those reaction times, which is wonderful. So what we've seen today is that this traffic Ouroboros can be avoided with self-driving cars on the road, even if we've got a mixture of self-driving cars and monkey-driven cars on the road. The traffic moves a lot better, and so that'll be fun to play around with different scenarios. If you've got other suggestions for scenarios for me to try, let me know in the comments below. What we're ultimately trying to work toward is intersection management, and so that's the next major thing that I'll start working on, is having these lanes intersect and having the cars talk to each other about who can go through the intersection when. So thank you so much for watching. I will see you next time. Bye bye.